Hello everyone, welcome to this presentation. This presentation is about understanding intonation trajectories and patterns of vocal notes by Jia Dai and Sam Dixon from Queen Mary, University of London, Center for Digital Music. Okay, shall we start? Unlike fixed pitch instrument, which holds the same pitch over time, the voice requires careful regulation during each note in order to maintain a steady pitch. Previous studies have investigated singing performers, which take single notes as an element, such as intonation accuracy, pitch drift, while the note trajectory within the notes has hardly been investigated. The aim of this paper is to study pitch variation within vocal notes and what factor influence the various parts of a note. The target is the four-part singing, which including soprano, alto, tenor, and bass. We recruit 20 people as our participants, 5 as a group. And they may have different listening condition, which hearing 0, 2, or 3 other vocal voice. To achieve this target, we designed a novel experiment. So there are 20 participants come from the Music Society of the university, and there are 5 groups of them. Each group have 4 different vocal parts. There are 3 listening conditions, depends on whether they can hear or cannot hear a live partner. I will tell you more detail in the further slides. So the music material we choose are one classical choir and another jazz music. For the measurement, we measured intonation accuracy by pitch error, melodic interval error, harmonic interval error, and pitch variation. We actually measured 2 different things in this experiment. One is the pitch error, which defined by the difference between observed pitch and score pitch. Another stuff is pitch stability, which is the variation inside an observed note. If you can see the figure in the right, the black line represents the median of this pitch. So we extracted the median of each pitch to represent the pitch of the whole notes. But we still keep the pitch stability or the pitch variation for each practical notes. As you can see, it's the green marks here, which show that the people's pitch actually varies when they are actually singing. There are 2 different interval errors in this experiment. One is called melodic interval error, another is called harmonic interval error. They are defined by 2 different intervals. So if you can see the figure here, the melodic intervals means 2 adjacent notes, where harmonic interval means the 2 notes that actually play simultaneously. So the interval error actually is the difference between observed interval and score interval. There are 3 listening conditions in this experiment. The first is closed condition, which means singers cannot hear each other. They are singing solo. Another is partial condition, which means we isolate the one vocal part, put her or him physically into another studio, and control whether she or him can be heard or hear other 3 singers. The last one is called open condition, which means it's like the normal choir rehearsal, that singers can hear each other's. In the experiment, we actually ask participants to repeat 10 times for each piece of music. And for the first and the last one was open condition, which means 4 singers are singing together. But for the middle 8 repetitions, we isolated singers one by one. The order actually isolated singer was randomly chosen. So for example, as the figure show here, the first one we actually separate soprano, and then alto, tenor, and bass. And when the soprano was isolated, we control whether they can be heard by other 3 singers. If other 3 singers can be heard by soprano, but the soprano is missing from other 3 parts, it's called 3-to-1 condition. If a soprano is singing solo, but other 3 singers can hear her, it's called 1-to-3 condition. So when the soprano sings solo, we use that as our closed condition. and the one actually can be heard by others, called independent singers, if she or him singing solo. But if the singers hear other people, which we called dependent singer. 20 adult amateur singers with choir experiment volunteered to take part in this experiment. 10 of them are male and another 10 are female. They come from the University Music Society and A Cappella Society, and another local choir. The age range is from 20 to 55 years old. And they agree to recording and video and audio through the experiment. Participants were paid £10 for their participation, and they are able to sing their part comfortably, and they were given the score and simple audio at least 2 weeks before the experiment. 2 acoustic isolated rooms are used for this experiment. Studium number 1 is for the isolated singer, and Studium number 2 is for 3 or 4 singers, as well as their speakers and microphones. And another is a control room, which controls the loudness for each speaker and microphones. Here are 2 pictures from the experiment studio. The singers were recorded in 2 acoustically isolated rooms. For the partial and closed condition, the isolated singers were recorded in a separate room for another 3 singers. Loudspeakers in each room provide acoustic feedback according to the test condition. There was no virtual contact between singers in different rooms. So here is an example. Before each trial, the singers will hear their reference notes, and a click sound tells them the tempo of this pitch. Okay, shall we start?
Yeah.
As you can see, each singer has one microphone, and there are 1 speaker before them, and 1 singer actually was isolated to another room when there is a partial condition. And the example shown here is an open condition for the number 4 groups, which sounds the second music, to be or not to be. If you notice that there is no lyrics in this experiment, participants actually sing ta 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 rather than lyrics. The experiment collecting over 400 files and up to 49,000 single notes. All of them are half manually checking and annotated by the first author. It takes about 67 hours to finish all the annotation. If you can see the figure here, it's the panel of the software Tony. So we can see each note and the variance for each note. And the blue bar means the median pitch of that note. So after that, we export all the data to a CSV file, and for now, it's available online. Okay, the next one is the results session. Actually, there are 2 sections including in this results session. One is about external notes. Another is internal notes. If you could remember how we defined the pitch error, there are pitch error for the whole note and pitch variance inside the notes. So let's talk about it in details. For the external notes, we found out that the bass part is the most special vocal part compared with the other 3. We observed significant difference between individual and interactional intonation. More specifically, singing without the bass part has less mean absolute pitch error than singing with all other vocal parts. If you can see the table here, singing without bass part, actually the whole group are more easy out in tune. And other parts, if we isolated soprano, alto, or tenor, their partial mean absolute pitch error is comparatively larger than when we isolated bass part. The second result of external note is mean absolute melodic interval error increases when participants can hear each other. If you can see the table here, if they sing in open condition or partial condition, their mean absolute melodic interval error actually increased, which means that if you can hear a leaf pattern, which will increase your pitch error in terms of melodic interval. It's very hard if you sing with other people, isn't it? We observed increases in pitch error and melodic interval error when singers could hear each other. The closed condition has the smallest mean absolute melodic interval error, while the open condition had the largest one. At the same time, acoustic feedback decreased the harmonic interval error, while the direction of the feedback did not influence the harmonic interval error. To be more specifically, mean absolute harmonic interval error is higher in the one-way interaction condition than the two-way interaction condition, and the singers produce more stable notes when they sing solo than with other participants. Let's talk about some results about internal notes. The analysis is based on both absolute and relative timing of the notes, where the initial and final transient are about 120 milliseconds, or about 15 or 20% of the note duration. The results suggest that the adjustment of pitch at the end of the note is governed by absolute timing. For example, due to the physical factors rather than the relatively timing, which might imply a musical motivation. The transient components vary according to the individual performers. For example, previous pitch, next pitch, vocal parts, and sex. So after analyzing all the individual notes and extracting the overtime, we observed the following regulations. There is a pattern for the vocal notes. As you can see the picture here, we observed that the singers tend to overshoot the target pitch and then adjust downwards after singing a knowing pitch, while after a high pitch, they try to reach the target almost immediately. The steady state pitch is 1 cent sharper when come from a lower pitch than when the previous pitch is larger. Singers also prepare for the pitch for the next note at the end of each note, as evident by the significant difference observed between a higher or a lower pitch next. We also observed a general expansion of harmonic intervals. About 8 cents pitch difference is observed between adjacent vocal parts, which is soprano singing sharper than male singers flatter than the target pitch. Female and male singers also differ in their initial transient, with female trying to have a upwards slide at the beginning, but the female have a downwards one. Participants with the fine pitch accuracy tend to have a smoother pitch trajectory, while the less accurate singers have relatively unstable note trajectories. If you can see here is the note trajectory of 4 different vocal parts. So last 2 are tenor and bass, they are male singers. The first 2 are soprano and alto, they are female singers. They have a different transient part at the beginning. For the 2 female vocal parts, they tend to have this kind of variation, but for the female, they just go to downwards. But at the end of the notes, they actually tend to have the same note patterns. So their note transient part at the end tend to be downwards. Here are more relevant publications, and there are a few conference papers and another journal paper under review. And if you're interested about this topic, welcome to look at my PhD thesis as well. And all the data actually are available online. If you can look at the data availability section in our paper, there is a link. You can find more data and more information. And many thanks to all the participants who contribute to this project. And thank you for your attention too.